So a child's brain is very different to an adult's brain, and we know more about the brain than ever before. So it's not like a hand where, if we x-rayed an adult hand and a child's hand, they'd be essentially the same, just different sizes, but the same muscles and bones would be there. The child's would just be smaller. That's not the case with a child's brain. It's not just a mini adult brain. It's completely different because different parts of the brain develop at different rates. So throughout the lifespan, a child's brain will be more developed in some areas than others. So there are parts of our brain that as adults we use all the time, every hour of the day, but in a child, that part of their brain is not developed hardly at all yet. The other thing we know from kind of brain imaging technology is that children's brains are over-connected and they're under-specialised. So what I mean by that, and I'll talk a little bit more in the later slides, is that younger children have lots more connections between their neurons in the brain, because over time, the neural pathways that we don't use very much and we don't need get pruned away. So as adults, our brains are much more efficient machines. When we're doing a certain task or we're thinking through a certain process, the neurons that fire, the ones that connect and light up for that particular task are very well honed. It's just that particular pathway that will light up. Whereas for a child, lots of different areas of the brain will light up every time they're doing a task or an activity because their brain hasn't quite learnt yet exactly which pathways they need. So they have lots and lots of connections, and all of those connections and pathways are being fired simultaneously. And that's why for children, it's a lot harder to process information and it takes them longer. And to kind of form new behaviours and new neural pathways takes a long, long time and lots of repetitions. The other thing we need to remember is the prefrontal cortex, the front part of the brain here at the top, which is responsible for managing your emotions and planning out what to do, reflecting on your own behaviour. That's the slowest part of the brain to develop. So when we're working with young children, we need to remember that they don't yet have the capacity to do some of the things that we're expecting them to do. So this slide shows how the brain develops over time. And we've got a 5-year-old brain all the way through to a 20-year-old brain there. And what the colours there are showing you is that the kind of red and yellow and green areas are still developing. And the kind of purpley blue areas are the ones that are fully developed. So you can see that even at age 20, there are still parts of the brain that are developing. And at age 5, that whole frontal area, which is at the top of the image that you can see just underneath the red line, that whole frontal area, hardly any of that is blue or purple yet. Not until you get kind of to the middle of the diagram. So when children are kind of in adolescence or as young teenagers. And this is really important to remember because sometimes what we expect of a child emotionally is the equivalent of asking a 3-month-old baby to stand up and walk. We would never, ever have that expectation of a baby. We know that physically they are not developed enough to be able to walk at 3 months old. And yet sometimes with children, we have these unrealistic expectations where we expect them to really be able to be rational, to manage their emotions, to reflect on their own behaviour when they're maybe only 3 or 4 years old. And actually the parts of the brain that enable them to do that have not developed fully yet. So it's really important to remember that large areas of a child's brain are still under construction, and our brain doesn't finish developing in that way until around 25 years old. So this is just to demonstrate what I was talking about earlier about children's brains being over-connected. So we've all got billions of neurons in our brains, and the point at which those neurons connect is called the synapse. So the synapse is where 2 neurons meet, an electrical impulse can travel between those neurons and send a message. Okay, so when we do something, a message in the brain is being sent from neuron to neuron across these synapses, these little gaps. And that's what enables us to learn something new. And you can see in the image there on the right, this is kind of a wiring diagram of the brain. And so in a young child, they've got lots and lots and lots of these connections and synapses. Whereas in an adult brain, there are fewer of them because our brain has become more specialised. We know exactly what to do for any given task or situation. And so we just have a much clearer pathway that will light up in the brain when we need to access that information. Whereas for a child, it's a lot more scattergun with lots and lots of different connections and synapses that are all firing at the same time. And this is why for children, life can be very overwhelming. Their brain is really working hard all the time. Lots of different areas of the brain are being activated all the time. And it can be very confusing and overwhelming for them.